It is with great pleasure tonight that I am introducing Tim Podesta, who has a huge amount of experience in the whole area of project management, investment analysis, and how does energy markets work? What makes them fly? Short term, long term, it's all there. In the last few years, I've known him a while now. In the last few years, he's pivoted, as in all good businesses have done. He's pivoted into the world of hydrogen. And he is currently an independent consultant and a faculty member for the World Hydrogen Leaders Academy. And he's going to, I've asked him to just give you a little update on what that is and why for him it's important. But the most important thing you need to know is all about how do you actually train people about hydrogen investment and projects, as so many people are talking about this. So Tim is going to go a little wider than that for us tonight and talk about some places where hydrogen makes sense, and he's going to answer our questions about the whole area. Now, there is one thing I want you to know. If you looked at the picture of Tim on our website, you might want to know why he's wearing that red coat. That is because he is also a proper Toastmaster, a red coat Toastmaster, a master of ceremonies. So if any of you have got a wedding come up, I'm just doing a little plug for him now. He can also pivot that way too. So if I may, thank you very much, Tim. We look forward. Oh, if you've got any questions, would you put them in the chat, as Tim, I and Jane will be monitoring them and try to cover them all. Tim, take it away.
Thank you so much, Rosie. And it's great to see some familiar faces from Chiltern Speakers, where I also was a Toastmaster. I still am a Toastmaster, in fact. So I'll just do a quick sound check. Jane and Rosie, am I coming through okay? I've taken my headphones out. I'm working through the computer. Please tell me if there is any problem with the sound as I go through. So that's a very kind introduction from Rosie. And in terms of, just to reinforce a couple of those points, I suppose there's three things I've written down here I wanted to share about myself, to give a bit of a sort of credibility for why I'm here. The first one is my background is oil, gas and energy. And I celebrated 35 years with BP in 2016, completed my time there. Since then, I've been an independent consultant, and I have, as Rosie said, majored on the world of hydrogen. Now, hydrogen isn't new to me. I worked with hydrogen. I worked on refineries in the oil and gas business. I also worked with gas business very much, and hydrogen business has strong parallels with gas, and I'll show you that as I go through the bit of background on hydrogen. World Hydrogen Leaders, and that's an organization which has grown up, particularly in the virtual world, to provide events, training and masterclasses and support to the growing global interest in hydrogen. Hydrogen is everywhere, and I'm going to say that a few times today. And as part of that, I do training online, I do masterclasses in person, and I've actually acted as a master of ceremonies for hydrogen conferences, most recently in Milan, which was great fun. And the third thing is, as a Toastmaster, I've been involved not only with Children's Speakers, but as a red coat. And so being a master of ceremonies of special events is one of my portfolio things that I do. I'm going to share some slides now. I'm happy for chat to come in the chat box. And actually, if at the end, we're going to leave at least 15 or 20 minutes for discussion. So I plan to get through my material in that time, and then deal with any particular burning questions as we go through. So let me make sure I share the right screen. I've had experience of sharing the wrong screen in events, which can be quite embarrassing, particularly if it shows emails. But anyway, so you should be seeing my screen which says a future with hydrogen. I always like to start with when I first came across hydrogen. And what you can see here is, I hope you recognize this, the periodic table. It takes me back to my chemistry class at school in Uddingston near Glasgow. And my favorite teacher, one of my favorite teachers, we all have favorite teachers, one of them was my chemistry teacher. He was Mr. Brown. He was also the deputy headmaster of the school, but he was a very dramatic type of teacher. And he wanted to do experiments to show us things, and he wanted to show us hydrogen this particular day. we're all set up in our benches in the typical science class. He was on the bench, had the bench at the front of the room, which was raised up, and he had a nice large bowl of water there. He was going to show us some hydrogen. So he got this little jar of potassium. And he got a little slice of potassium and he placed it in this water and it fizzled around, and he was going to try and catch some hydrogen. So he got a little test tube. He tried to catch some hydrogen. He failed, but he wasn't going to be put down by that. So he said, right, we're going to try again. So he got a larger chunk of potassium, put it in the water. It fizzled around. He got a slightly larger beaker. He tried to catch it and pop. There was a large pop, and it caught everyone by surprise, but that showed the power of hydrogen. And in fact, that sound, I was reminded of that recently. I actually heard that sound recently again. I'll tell you a bit about that as we go through. So hydrogen, I'm sure you can remember hydrogen from your school days. 3 points I want to leave you with today as things to take away. Hydrogen it's actually all around us. It's nothing new. Secondly, we need to get ready for hydrogen because it's coming. We're seeing many sort of pilots of this application or that application. And as a replacement for hydrocarbons, it is certainly a useful tool. When you burn hydrogen or use hydrogen in a fuel cell, you produce water. So the carbon dioxide from hydrocarbon is abated, is avoided. And thirdly, like gas, like natural gas or LPG, liquid petroleum gas that we might put in some cars or use in for cooking, we just need to take care with it. It can be hazardous, and so just like gas, LPG, you need to take care with it. Hydrogen is all around us. The sun is 70% hydrogen. Most of the rest is helium, and the fusion, the sunlight that we enjoy, the main source of energy for much that happens on the earth is from the fusion of hydrogen. Organic compounds, and hydrogen is a big part of plants, of humans. I think 10% of human body is effectively hydrogen, probably water. And I've highlighted ammonia there because ammonia is the product which is the most use of man-made hydrogen is used in the making of ammonia. And one of the big things is converting that man-made use of man-made creation of hydrogen. It actually uses gas, and I'll explain that process a little bit in a minute, but it also produces CO2. So that's one of the big areas. They're actually having a natural source of hydrogen, a green hydrogen, as some people call it, can make a difference. It's in water, and actually is in hydrocarbon. So it's all around us. In fact, those last two, the water and the hydrocarbon, are actually the places where we're most likely to get the natural hydrogen that we'd like to use for fuel, for energy. The thing about hydrogen, it's very, very attractive. And actually, it doesn't naturally occur on its own. It's always attached to nitrogen in the case of ammonia, or hydrogen in the case of water, or carbon in the case of hydrocarbon. So to actually have the hydrogen to be able to use, it needs to be a process behind it. A bit more physics. Hydrogen. Some people think that hydrogen is the new oil. Now, I'm not so sure about that, because if you look at hydrogen and its properties, it actually is more. It's not dissimilar to gas, to methane. And compared to methanol and gasoline, which are the fuels which are more common today, liquid fuels, it is quite different in terms of molecular weight. Some interesting characteristics of hydrogen. Its actual density is very, very not dense. It's much less dense than even methane. And that is an issue in terms of if you're looking to use it as a fuel, to actually to move it or store it, you need to compress it even more than a normal gas, normal methane. One advantage it has is viscosity. Now, viscosity is useful for products because that's the friction if you're moving products through a pipeline, which is something I'm very familiar with from my background. But it's actually, because it's a lot less viscous, 10 to the -5 rather than 10 to the -4 in terms of methane, it's actually more easily transportable through pipelines. And one of the issues with any fuel is moving it from its source to its consumer. Boiling point, it's not dissimilar to another difference with methane. Methane is -162 as a boiling point. So if you want to liquefy methane, you have to go quite cold. But for hydrogen, you have to go even colder. So if you're transporting hydrogen, then you need to liquefy it to even colder temperatures, which is can be more costly. If you look at the world of gas today, liquefied natural gas, a big part of it is actually the market is in transporting liquefied natural gas around the world in tankers. And we're hearing a lot about that at the minute in terms of the supply of gas to globally. And one of the drivers is the scarcity or the need for liquefied natural gas to replace gas from other places like Russia. The other useful thing about hydrogen is its heating value. Now, this is a range of comparable products. I think that what I want to highlight here is the fact that hydrogen actually packs a punch. It's actually almost 3 times more energy per kilogram compared to natural gas. So although it may be less dense, but when you get a kilogram of hydrogen, you get more energy from it. So that's on the plus side to offset against the fact it is less dense as a fuel. So getting ready for hydrogen. This is how it will impact our lives going forward. It's the opportunity that could be part of our supply in the homes. Ultimately, you could have all our gas appliances running off hydrogen. In fact, there are some trials going on about how that might come about. I want to give you a little bit of background on the UK strategy for hydrogen, which I've done some deep analysis on. The UK has a strategy for developing hydrogen. And also fuel cells, which is the device which will effectively use hydrogen in various applications, and transportation in particular, to convert the hydrogen to electricity to provide motive power. And that's something that is well advanced, and there are examples of it in practice, which I'll share. The hydrogen home. I wonder if you can imagine living in your normal house, and actually, instead of having natural gas coming through your pipeline as your supply, as many households in the UK do through the grid, it could be hydrogen. Well, what you're looking at is a hydrogen hub. I had the privilege and the pleasure to visiting the hydrogen house, and there are a number around the UK. This is one particular one near Gateshead, near Newcastle, and you can see there that I was with a group of people, and there's a lady who's actually testing whether this is actually working or not. Yes, it is producing heat, and she's being very brave and putting her hand on top there on the right. She was actually a strategy manager from an Indian infrastructure company, because they're looking at how they might convert their pipeline system to running with hydrogen in the future. And clearly, the use of hydrogen economy very much depends on there being demand for it. So this hydrogen home is fully kitted with a hydrogen boiler and with a hydrogen hob. And it just looks like a normal new home. But there are various questions around it that people are asking, and in doing this, they've done a lot of quite notably done a lot with public. In fact, next door to this hydrogen home, there's a part of a village near Gateshead which is actually running on blended hydrogen. So in their gas supply, they've had 20% of hydrogen blended into their hydrogen feed. All their appliances have been checked and set up, and many of them, being more recent, were already set up to run on a blend of hydrogen. And it is possible for many appliances to run on a blend of up to 20% hydrogen. Now, that means it's still 80% gas, but there means that there's a reduction in the amount of methane being used. So in doing that, one of the questions is, well, if I have a hydrogen hob, how does it affect my recipes? So what they've had is they've had someone, part of the team who've been looking after this hob, has been going in with to cook their regular meals in this house, and the feedback is, well, it's no different. The sort of the amount of time, the amount of level of heat is just the same. Two subtle differences in terms of what it looks. I was quite pleased when I saw this hob to see there is a flame here. You definitely see it when you're on a max gas. When you turn the gas down, the flame does start to sort of go small, and it does lose a bit of color. So what it has actually on the hob, I'm not sure if you can see that, it has an LED light which comes on to say that there is gas flowing. So there's consideration for making sure that there's no mistake that gas is left on, and even if the flame isn't as prominent as you might like. Is it safe? Well, there's no. It is safe. The intent is there's something called mercaptan, which is put into natural gas to give it a smell. And that's what if we have a leak, it's not the gas we're smelling, it's this trace of something called mercaptans. The same is to be used, probably used with hydrogen. In fact, the blend of 80% gas, 20% hydrogen has that same mercaptan in it. So it's no different in terms of if there's a leak, you smell it. Does it leak? Well, it doesn't leak any more than gas. If you've got a gas-tight system, natural gas won't leak, nor will hydrogen leak. But if there is a leak, because hydrogen is less dense, it will leak at a higher rate. The more hydrogen will escape, but the rate of leak is actually less than the calorific value. So whilst it's not good to have hydrogen leaking, you're not losing as much energy as if you had a similar gas leak, put it that way. So there is a trade-off there. So it can leak, but it won't leak any more. It won't leak more often than natural gas, and if it does, it won't be. It won't have it'll have. It might be more gas leaking, but it won't be so much that you're losing so much energy, put it that way. And there is a debate around, well, actually, methane leakage is considered an issue for global warming. And in the same way, there's a view that hydrogen leakage is likely to be an issue for global warming. So whether it's natural gas or hydrogen, the efforts to reduce leakage are equally important. So should be no let up in the attempts, in the work done to reduce any leakage of any gas. So that's the hydrogen home. Hydrogen production. There are basically two routes to hydrogen production. One is extracting it from natural gas, from methane. One is getting it from water, where I mentioned earlier that hydrogen is all around us, it's in those places. To get it from natural gas is something called steam methane reforming, or sometimes people call it SMR. And basically it's quite a simple but intensive industrial process where you have gas and steam at high temperatures, 900 degrees or more. And through that, you get a breakdown of the gas into a syngas, and then you're able to separate the hydrogen out, purify it, and then that hydrogen is available for use traditionally to make things like ammonia, or it may be used in refineries as part of some hydrogen-based refining processes. That produces a lot of CO2, and that is why it's given the term grey hydrogen. It's something which is not compatible with decarbonisation. The step beyond that, the second bullet point is where you do the same process to make the hydrogen, but you capture the carbon, and you use something called an amine extraction. And then what you then need to be able to do is to minimize any CO2 release, and that CO2 is then captured and put back into the ground. That's entitled, that's called blue hydrogen. The challenge there is to actually minimize any carbon production, but it is potentially, when we have a quick a look at the UK strategy for hydrogen production, it is the likely route to larger volumes more quickly to support development of a hydrogen economy. And finally, electrolysis. And this is where, in simple terms, you put electricity through water, and you have, I guess, the two terminals, the anode and the cathode. The anode being the positive, you get the oxygen, and the cathode being the negative, you get the hydrogen. And then the process is then one of capturing those gases which are produced. Now, the technology is quite advanced. There are different routes to doing that, either with an alkaline solution, a liquid solution, or more solid solution with membranes. The importance of that is, if you're able to produce that electricity from renewable sources, whether that be wind or solar, or in France, they're looking at possibly doing it from nuclear as well, but certainly from wind and solar. This is where the way I like to describe it, it's my wish for the climate. So my wish being a tangible thing, it's wind and solar along with hydrogen, and then wind and solar producing the electrons. Hydrogen is one of the things you can use electrons for, but electrons can be used for other things. So I think one of the other points about hydrogen I want to make is that it's not, it's part of the solution to decarbonisation alongside electricity. In fact, when I look at the investment case, Rosie said earlier on, my interest and expertise in investment cases, whenever I look at an investment case that someone is suggesting might be viable for hydrogen, I say, well, what's the alternative? Well, the alternative in many cases is electricity. And we'll see that when we look at the electric car, for example. Now, I see there's lots of chats coming through. I haven't taken a moment to look at those. I know one was about cars. Well, will we come into cars? And in fact, I'm not sure that's an area for discussion, more detail later, because I know that particularly the discussion around diesel versus electric, petrol versus electric, hydrogen is sort of is a sort of third part of that debate. So in terms of the UK and the scenario for 2030, the government have proposed that there should be 5 gigawatts of new hydrogen production without carbon, well, effectively clean hydrogen production by 2030. They then increased that to 10 gigawatts with the energy security the update, as it were, to counter the energy crisis in the global market. And what I'm showing here is a map of Great Britain. It has three types of symbols on it. It has the CO2 bubbles, and those CO2 bubbles are actually places where the CO2 could be re-injected, could be captured and put back into reservoirs underground. It's a proven technology. And those are the areas of the UK where there exist those reservoirs today. The large green circles, Southampton, South Wales, Humber, Merseyside, Teesside and Grangemouth, those are the main areas of industrial emissions. And those are the areas which are part of the target for having hydrogen to replace existing use of hydrogen, and also to use hydrogen for industrial heating and as a way of decarbonising those industries. Now you can see there's some natural connections between those, and the blue triangles are where there is a project on the blocks today to produce a blue hydrogen plant, steam methane reforming with carbon capture. And you can see there where the carbon capture is going. It's actually, it's something which can be done certainly with investment. It's actually an extra project to be done, but there is this clearly a link. There's the opportunity to capture that carbon. Now, the actual industrial producers and emitters of CO2, it's not just for hydrogen. There will be other industries which will be looking to do carbon capture from the fuels that they might use, whether that be gas or even, it's unlikely coal, but maybe some of the oil, some other industrial producers as a route to reducing their CO2 emissions. And then what most interesting for me is that the green symbols. There's the green triangle, which is the link potentially for big hydrogen from Scotland, Scotland being one of the windiest parts of Europe, and large offshore capabilities in terms of the recent licensing round, potentially up to 40 gigawatts of wind power off the coasts of Scotland. Now, Scotland only needs 4 gigawatts of electricity for its own use. So there's a clear opportunity then for some or a lot of that electricity to be made into hydrogen. And there are 3 examples that I use in my courses where I look at investment cases and project practices. There's this use for transportation, it's used for industrial heat, and that's in the Cromarty Firth. And for Scotland's biggest industry, it's for whiskey. And so there is certainly one project, and hopefully many projects, where whiskey distilleries will use hydrogen instead of LPG or gas or even oil to heat their stills. And the one project which that I've looked at quite closely is looking to provide the heat for 3 distilleries in the Cromarty area. One is Glenmorangie, and then Diageo, and then White Mackay. So those whiskies will soon, hopefully in not too distant future, we'll be able to have a green dram from those. So that gives you a snapshot of the strategy and how the blue and the green. I mean, the colours are helpful in understanding the sort of source of hydrogen, but hydrogen is hydrogen. And the key thing about the hydrogen is if it's going to be produced for use, it needs to be produced in a way which has minimal emissions of carbon. So I think I want to move quickly on to talking about cars, and then leave some time for discussion. So in terms of large-scale hydrogen, one of my favorite projects is Shetland, where I did my early engineering training at a place called Sullenvoe. And they've got a scheme there to effectively capture electricity or hydrogen from, either make the hydrogen onshore or even offshore, and find a way of getting it to a market, probably an export market. Issue with wind power is 2 things. One is the load factor, and the other thing is curtailment. There are big wind farms. One of the biggest ones is in Scotland. And as more and more wind power is put in place, there'll be more and more curtailment. Now, curtailment is the act of telling a producer of wind power to stop, because we can't use all the power you're producing. You're producing too much wind, Jimmy. You need to shut it down a bit. In 2018, I think several tens of £millions were paid to the producer of electricity at this particular location to stop, to reduce their production of wind power. An opportunity there clearly is to use that power to produce hydrogen, and there is a scheme to produce hydrogen for buses in Glasgow. Cromarty Firth, as well as this distillery scheme, they've got a grand scheme to develop skills and also an industry supporting the offshore wind. So there's a strong connection between offshore wind and hydrogen, which will be a big part of the Scottish economy going forward. Fuel cells. This is where hydrogen becomes useful for transportation. Now, this gentleman is Tom Bacon, and behind him, he was an engineer in the 50s at Cambridge University, where I studied engineering. Behind him is a fuel cell. he developed a fuel cell which was then licensed by Pratt & Whitney. Pratt & Whitney then applied it to the Apollo program. And effectively a fuel cell is the reverse of an electrolyzer. So effectively you mix hydrogen and oxygen together and you get electricity and water. So this was very useful for the astronauts going to the moon, because they, as well as they ended up, they had hydrogen, which was also used as a fuel, and oxygen as part of the payload. In the fuel cells, they were generating electricity for life support, but they also produced water, and it produced an element of air conditioning as well, because there's some heat emitted as part of the process. And what that means is that it's not new, but its application is quite new in these different areas, from buses to trucks to trains to planes and automobiles, question mark. Hydrogen has an advantage in terms of its use, what I describe for heavy duty. So heavy duty is where you're doing long distances, long time duty. You want to be operating, you want your transport vehicle to be able to be operating, not necessarily, well, for most of the day, day after day, and load. If you've got a heavy load, then you need sort of the ability to generate power. Buses is one good example. Glasgow, COP26, there was a lot of interest in projects around Glasgow's going green. But Glasgow's bus fleet is about 800 buses, and they have an aim to develop at least 100 hydrogen buses, 50 of those initially, to cover the route from Edinburgh to Glasgow. Now that's a long distance route, and it's buses which are running most of the day. And the rule of thumb is that if you have a hydrogen bus, it's equivalent to a diesel bus. If you have an electric bus, you need 2 electric buses to do the same duty as a diesel bus, because of the issues of load and duration. They need to recharge. I did get to visit a bus filling station in Barcelona. So these things do exist, but I think it's a sign of how the hydrogen business opportunities are developing. A lot of money has been put into developing this fueling station in Barcelona by an organization called Iberdrola, who are actually own Scottish Power. So they are a big organization. And it's organizations that have that financial strength and reputational ambition that are making these investments. And this is not a cheap site. In fact, some of the facilities are actually quite impressive in terms of engineering design. It's there to service the Barcelona bus fleet, several hundred buses, I think similar to the size of Glasgow. At the moment, they've got 1 hydrogen bus, and there's 5 more coming. But this facility is designed to handle up to 30 buses, and then be available for other transportation organizations to come along and fuel up. So it is coming. And the hydrogen buses are coming. Fuel cell trucks are coming as well. They definitely have a role to play in long distances, and this is a study that I've looked at in some detail which supports that fact. Electric versus petrol. I do this because for 2 reasons. One, I've actually, this is a very personal comparison for me, but also it's a good one to make at the same time as looking at hydrogen. Clearly in terms of the fuel costs, comparing an I-pace to an F-pace, you're comparing electricity to diesel or petrol. For a 50-mile journey, it's got some numbers here. This was probably valid about 6 months ago. With recent developments in fuel prices, we've definitely seen the electricity. I think it's probably still about that. I worked out, I've actually been driving an I-pace for the last 2 months, and I did work out that I reckon it cost me about £5 if I pay 28p a kilowatt hour for my electricity. Clearly cheaper if you can use an off-peak rate. And then the fuel, I think it's probably more like 15 or 16 pound now, but clearly it's much cheaper to be able to use electricity as it stands today. Remembering that electricity cost includes a lot of fuel duty and VAT, about half of it. When we look at hydrogen then, we're looking at a car with a fuel cell. This is the Mirai, which is one of the, it's a Toyota, which is, I think, one of the cars which people talk about quite a lot in terms of hydrogen. It's been around for a little bit of time. Has a range of 400 miles and 142 litres of fuel capacity, which is about 5 to 10 kilograms of hydrogen. And the cost is if that hydrogen, I wrote the number down here, if that hydrogen is at about 10 to 15 pound a kilogram, then you're talking about 50 to 75 pounds to fill the tank. So it's comparable to diesel and petrol, but one of the things that you'd hope hydrogen would get would be an advantageous position in terms of fuel duty and VAT. It means the government's going to be getting less take if it does that. And it's the same with a number of areas where hydrogen could be employed. The truck example I showed earlier in Europe, one of the things that can help the investment case for the truck is if those trucks don't have to pay the tolls. Well, that's fine, but then if whoever is not receiving the tolls for use of those trucks, that there's going to be a shortfall in their revenues. So there's a balance in terms of how these things are supported by fuel duties and tolls. This is a nice comparison in terms of where we are today. If you wanted to get a fuel cell car, you'd probably be paying twice as much, but you would probably enjoy some good fuel economy, as well as not producing any CO2. Clearly, an issue with hydrogen is, like with electricity, is where you can refuel. Now, hydrogen, if you can get to a refueling point, you can probably refill your tank up quite quickly, almost as quickly as a diesel or petrol, but then you'd have to. The issue then is where there are fueling stations, and that's why what I'm seeing is hydrogen is transportation hubs are popping up near where hydrogen is produced. The map I showed earlier of the UK with those hydrogen production sites, I think most, if not all of them, they have a range of potential consumers, and one of them is hydrogen transportation hubs, and they are likely to be available for local fleets, whether they're trucks, buses, and presumably available for the public to use as well. But one of the issues with hydrogen is the development of a hydrogen network, so that there could be fueling stations if you wanted it for cars. And the thing about the hydrogen car in terms of efficiency compared to electric car, with the electric car, if your source of energy is truly green, truly renewable, and available and local, the thing I forgot to say about my eyepiece is I actually charge it with solar power from my roof, which is so actually it's a lot. It actually feels like it's driving for free as long as the sun is shining. If you can get that renewable electricity to the car cheaply and it's available, then actually it is more efficient than that same sort of process with hydrogen. The thing about hydrogen is that certainly in wider application as a source of energy, it can be stored, whereas renewable energy can't. Now, I've not said a lot about that, but one of the things about hydrogen being an alternative to electricity is actually can be worked together. There are a number of schemes. In fact, there's one being financed in Guyana, where they are making solar energy, satisfying the local market, using hydrogen as the storage. so they have a electrolysis of the electricity to make hydrogen, and that's then fed back through fuel cells to provide a levelized load. And hydrogen versus diesel, they're clearly hydrogen being more dense in terms of energy, it can be advantageous. I won't dwell on this one. And will hydrogen be the new oil? I should credit this picture behind me from a study by Arthur D. Little entitled Will Hydrogen Be the New Oil? Well, I think my view is hydrogen is certainly part of the new energy solution. I don't think there is really a new oil. There is another subject to consider another time, and that's synthetic oil and bio-oil, biofuel. But with a focus on hydrogen, hydrogen in one sense, I think in one sense, and the new gas. Although that 10 gigawatts of gas I showed you earlier as the ambition for 2030, that's only 10% of UK's current gas consumption. So it'll certainly address key parts of the area, but I think alongside electricity, hydrogen, I don't think, for me, certainly not new oil, but it's certainly a useful replacement for gas going forward. So hydrogen's all around us. I hope I've given you some examples of what it means to be getting hydrogen ready. But if you like gas or LPG, please take care. I think I've left myself some time for discussion. I did spot some of the questions around about transportation. But I would appreciate some help from Rosie and Jane in terms of some grouping of those questions and best way of addressing them.
Okay, well, thank you very much, Tim. And a lot of food for thought. I hope not too incendiary food. Obviously, one of the big questions right at the beginning in everybody's mind, and I think a certain accident that is still famous from hundreds of years ago, it still comes to mind, is boom on hydrogen. How much should the public be worried about that?
I think one of the reasons it's for my third point, which is like gas or LPG, we take care. And I think we shouldn't be more worried than the sort of natural precautions we take with gas or with LPG. One of the things they found in doing this trial in Gateshead is that consumers have confidence in the organizations which is applying the gas and the appliances, and therefore they weren't any more concerned about using a blend of hydrogen and gas than not. And there still needs to be a lot of, and there is an intention to have hydrogen villages in the near future, and I'm sure that'll be part of their the work they'll do there is the working with the communities in terms of making sure that they're happy and they're confident what they're using.
Okay. Can I suggest, Tim, if you pop the PowerPoint off, it'd just be a little bit more convenient for seeing the chat. The other thing that's come up quite a lot is the economics of this. Yes. Producing the hydrogen is taking a lot of energy. So if you're looking at it from a very simplistic point of view, until you mention storage, one of the questions in people's minds is, well, if you're making the electricity to make the hydrogen, why aren't you just using the electricity? Because there's losses. Once you've made it, you've got to spend energy making containers, etc. So can you just say a little bit more about, in terms of the overall sort of, if we did life cycle of hydrogen, where are the big, there's the energy to make it, but there's the energy to store it and shift it down pipelines, etc.
Yes. So there's two angles to respond to that. The first one is that there are some uses of hydrogen, like in making ammonia, like in providing what I describe as high temperature heat, heavy duty heating, something like this, the stills for making whiskey, and for those, electricity isn't really an option for those sort of duties. Well, certainly not for making ammonia. And the second one is, particularly when we look at renewables, my wish: wind, solar, and hydrogen. Wind and solar clearly are variable in terms of the times of day that they're operating, and hydrogen in that capacity can be useful as a to make use of surplus, but also to provide storage. And in fact, whereas we may have relied on gas to do that in the past, in fact, some of the interesting schemes for hydrogen are actually using hydrogen for peak power production rather than gas. And certainly for those, hydrogen has a value in doing that. So but it's alongside electricity. So if electricity is available for a particular application, that's more likely to be attractive than gas. Gas has a niche role and also a balancing role.
Okay, yeah. So the key thing about hydrogen is possible, and I thought you really captured that with the transport. Some of those hard to reach transport where electricity isn't a solution. Hydrogen is making hydrogen is interesting way forward. Now, in the UK, we don't have yet as much renewable. We have some spare on very windy days. So a question Willem has put in is, what's the greatest barrier to hydrogen becoming a major fuel source? Is it the energy to make it and where you're going to get that? Or is there anything else that's a barrier?
The one that pops straight into my head is transportation. It's not dissimilar to issues with the gas business in the 80s and 90s, and it was how you get the gas to market. And a lot of investment went into pipelines. In fact, some of those pipelines could be repurposed for hydrogen. In fact, they're looking at from North Africa, if hydrogen could be produced there, they could reuse some of the existing gas pipelines. A lot of gas comes into Europe from North Africa. And then the transportation long distance from places like Australia to the Middle East in liquefied form. And I think, and then I mean, Scotland could become a big exporter of hydrogen. There are talks of there being if with this effectively surplus wind electricity, there is work going on looking at schemes where you could actually produce hydrogen at the offshore wind turbine, and that could then be collected and moved to market, whether by pipeline or by ship.
Okay.
Transportation is probably the biggest challenge. Cost clearly is as well, but transportation, I think, is probably, with transportation you get access to creating of a market and potentially combined with cheap and surplus renewable electricity, then the price should benefit.
Okay. Another question is, if you're going to inject, for carbon capture, yeah. There's quite a detailed question here. What's the cost comparison between underground injection versus solid conversion? So someone there who's thought about their carbon capture.
Yes, and maybe even a subject for another talk. Carbon capture is proven. It's been done over many years, and I've in fact, BP did a project in North Africa, and the Norwegians are world leading at carbon capture as part of their environmental push over the years. Cost of doing it, I think the issue is scale. The volumes of carbon you're going to be capturing, putting into the ground. You need a large reservoir and large capacity, and actually large projects to pull it all together. There are some schemes. There's an interesting one in Scotland to do direct air capture, which I think will certainly offset. Virgin looking at using that to offset their potential CO2 production. But that would be essentially what I've seen. It's the scale availability of capturing underground.
Okay. I've got an interesting issue that for some reason my chat, well, I've got nothing after 8:03, but I have seen
Yeah.
messages come up. So Jane, I'm going to hand back to you. Have you got some more questions after 8:03, or has something happened to the chat?
No, I haven't got any more questions on the chat, but I have a question.
Right, go for it.
I had understood that a big issue was storage because of the explosiveness, because of it having to be stored at a very low temperature. Can you elucidate on that a bit?
It certainly can be stored safely, like natural gas and LPG. If it's been transported as a liquid, then natural gas is transported as a liquid, so it will require similar treatment as far as storage. Clearly, it needs to be done safely, not stored in an air balloon like Hindenburg. That wasn't a good way of storing hydrogen, I have to say. That was something that you wouldn't expect to be done today.
But isn't liquid hydrogen needing to be kept at a very, very low temperature?
Yes, that's correct. And that's one of the disadvantages in having liquid hydrogen as a product which may be moved around the world. But I think there are examples of liquid hydrogen being shipped from Australia to Japan. I think that's already started.
So Tim, are there going to be parts of the world that have a natural advantage in becoming a hydrogen hub because of their easy access to or relatively low cost renewable? And is that going to change some sort of economic trades, if you like?
For sure. I think the best example I think of is probably North Africa, or even other parts of Africa, where if there's investment possible in developing the renewables, then if there's the infrastructure available, the transportation, and then they can become sources of revenue for those countries, as well as places where things could be made, like ammonia. Now, ammonia is an interesting one. I mean, the global need for ammonia, a fertilizer, is large today and likely to grow. If you can have ammonia production near where the hydrogen is produced, that's probably the best solution. It's not dissimilar with gas. If you can use the gas without having to transport it, that's the best solution. So I think there's definitely opportunities, schemes in Morocco. I've seen, and certainly the Middle East, they're seeing it as their next, almost like in a way of replacing their position in OPEC. They can become global suppliers of hydrogen or ammonia. I'm seeing in the chat some questions about concerns about driving around with hydrogen in the car.
Yeah.
I think that's similar. There are compressed natural gas cars, LPG. So I think shouldn't be any greater risk than those. Clearly, the safety is paramount in any of these developments that we would see.
That brings me to, I think I'm going to make it a final question, unless somebody else has got something burning, and that is coming it right back down to we, the consumer, sat in our house trying to do the greenest thing. If we're not near a hydrogen hub, so we're not in Orkney, yes, or Ross and Cromarty or Humber, we're not near there. What is the role hydrogen's going to play? Obviously, and we assume we all get a boiler which is able to take the 20% hydrogen, 80% methane. That's good. When do you see hydrogen playing a role in our future energy needs? If you've got 10 gigawatts by 2030, when will it start being part of, I would call, the average domestic situation?
Okay, well, you'll see hydrogen vehicles popping up all over the place. In Glasgow, they're looking for hydrogen, so refuse trucks as well as buses as part of that. You'll see them popping up. Maybe even travel on hydrogen buses. I think in terms of hydrogen in the home, I think it'll gradually grow. But I think it'll be part of the mix. So when you look at opportunities for decarbonising when you look at solar panels or heat pumps or alternatives to using electricity or just becoming more energy efficient. It's one of those things that could be part of the mix, depending, particularly if it becomes part of the gas supply solution. It's not, I think we're a couple of years from the government making some clear decisions on how fast we might go to using hydrogen. But certainly the gas transmission companies are working hard and looking at what they need to do. In those schemes, that Hydrogen Home I showed, the hydrogen trial, they've been done by the gas distributors, and they will be key in moving those opportunities forward. And you never know, maybe in the future, Tyler's Green or one of our local villages will become a hydrogen village.
Yeah, but what I'm hearing is, if you want to do something between now and 2030 yourself, there's an awful lot of infrastructure needed that an individual has no touching point to. It's probably a post 2030.
Yes,
or for many people.
Yeah, so yeah, I mean, it's all around us. You know, get ready for it, and just declare, and just like any other hazardous.
Right.
Yes.
So there's a question here. So I'm going to, do we have time for one more question, Jane, or do you want to stop?
I think it's a fascinating one, so I think you should go for it.
I think so. Thank you very much to Tim. Anybody needs to leave at 8:30. I know a few people have had to go. So I'd like to say a very big thank, and if everybody could just show a sign of appreciation visibly, that would be very helpful. But there is one really important question. There's going to be some winners and losers. Somebody's going to make a lot of money out of the hydrocarbon economy. So the question is, Tim, who's that going to be? Where is the most money going to be made in the value chain?
Well, there's two. In fact, Chris has just mentioned one. There's been some chat going on in the
yeah.
I think IT Empire make electrolyzers. I think electrolyzers are because they're the things which the devices which will be required to change the electricity into hydrogen or convert it. So I think that's one area. The companies that can scale up, and there's huge demand for that. And the other one I think is infrastructure. It's a bit like the early days, British Gas. That was not a bad place to invest. I think the companies which end up becoming the market makers or aggregators, I think they might be solid investments.
Okay. Well, thank you very much for that thought. I know all of us like to know where our investments should lie in the future. So it's an interesting food for thought. Can I pass us back to Jane?
Yes, thanks very much, Rosie. Thank you very much indeed, Tim. Obviously, like many of our speakers, you have far more knowledge about this subject than you could ever possibly manage to fit into less than an hour.